Okay, it's good. Now we're going to continue. First, we do one more arc length problem. So continue arc length. So yesterday we introduced the formula. Arc length formula is S equals from x to x0 to x1, 1 plus f prime over x dx squared dx. So we make some transformation, and it turns out to be equals to a to b square root of dx over dt square plus dy over dt square and dt. Okay. So whenever we use this formula to find arc length, it's much simpler. The reason is that when you take the derivative dx of dt is a simple function, dy over dt is another simple function. So two simple functions take derivatives, it also give you a function which is pretty simple actually. Okay, so then let's look at one more example. Suppose x equals let me see what we did yesterday. Okay, so t squared, suppose y equals 2t, and t is from, just make that like this, y equals 2t, and t is from 0 to 2, and find the arc length from 0 to 2. So now we find the arc length of this one, x equals t squared, y equals 2t. Okay, so we can see this is you can change this in rectangle formula is y equals y squared is 4, it's 4x, right? It's a parabola like this. Now you want to find the arc length from 0 to 2, from 0 to 2 like this. We're looking for this arc length. We're looking for this one, the red part, right? So what do we do if we use the parametric equation? Do it. It's pretty simple. From 0 to 2, 0 to 2 is t. Derivative dy over dt, dx over dt is 2t squared. Dx over dt is 2t, then square. Dy over dt is 2, so it's 2 squared dt. You see, it's a very simple integral. So it's just from 0 to 2, square root of 4t squared plus 4 dt. Well, the 4 you can take it out. Square root of 4 is 2. So 2 from 0 to 2, square root of 1 plus t squared dt. Okay. Well, this one you can let t equal t equal tangent theta. Anyway, you can use the formula, integral formula to do this, or you can use the integral to find out this integral. You can add t equal tan theta, but the 2 is not a special angle anyway. So if you use the formula, you get t square root of t squared plus 1 plus ln t plus square root of t squared plus 1. Okay, so from 0 to 2, then equals 5.916. Alright, so once you get to here, you don't have to worry about the result. You can, if it's not a simple function derivative, you can use formula. If it is a simple function formula, you can use the formula, or you can use a calculator if it's not easy to find the antiderivative, right? So that's another example for finding just the review of the previous work, arc length. You can see, take the antiderivative of first dx of dt, dy over dt, both give you very simple forms. You don't have to worry a long form of that. Especially yesterday, I gave you a very good example about finding the length of the circle, right? Alright, so next we're going to look at the area of a surface revolution. area of a surface revolution. And previously we got our the revolution formula. Let me see. There is a previous formula before, right? Okay. So I just write down the theorem for you first. So theorem 10.9. If a smooth curve, say given by x, if a smooth curve C given by x equals ft and y equals g of t does not cross itself on interval a and b, then the area S of the surface revolution formed by revolving C about the coordinates is given by the following. Actually, it's pretty simple. I can show you. The formula is pretty simple. Okay. First one, revolving x-axis. So first rotate it with respect to x-axis or revolution about x-axis. So if it's x-axis, for example, if it's like this, if I revolve this with respect to x-axis, you're gonna have something like this, right? You have like this one. It's going to be area of this one. You will revolve with respect to x-axis. Okay, so it's circle here like this. Revolve with respect to x-axis. We're looking for the surface area. All right. So what's the formula? The formula is S equals 2 pi from A to B and GT. Y is gt, x is ft, so gt 2 pi r times dx over dt square plus dy over dt square dt. Okay. Why is like that? This is 2 pi gt, so basically 2 pi gt is one of the circles, so it's like this. Okay, 2 pi r. Basically, if you look at one of them, you take a small one out. You still have this. Looking at the middle small one, just a small piece. Okay, so the small piece, the circumference of this one, if you take a very small piece here, the circumference of this circle, this small one, is 2 pi r. Right, 2 pi r times the 2 pi r times this dx, whatever the small one here, 2 pi r times h. You can do delta h here. So first is the circumference. Circumference of this circle is 2 pi r. The r, you look at this. The r is what? R is y values. For the in this picture, the r is y values. Is this y value? This is r. Okay, this is r. R is y values. So 2 pi r times the small change of the curve. The small change of the curve is delta t. The small change of curve is this one. dx squared over dt plus dy over dt squared dt. Because in the previously we just did the s formula. This is the s. This is curve length, right? Arc length. So now if you multiply by the small change of that curve and multiply by 2 pi r is the surface area of this one. Then you take the antiderivative from a to b, so it's going to be the whole thing. That makes sense, right? 2 pi r times the change of the small change of d del h here. Then take the antiderivative of the whole thing. Okay? Do you have any question? Okay, no question. So next one, revolution about y-axis. S equals in the other case it's going to be like this. You draw a picture, for example, like this. The surface area. So now it's 2 pi r this way. So r in this case is f(x) is x values. Okay, so x values. But we're given x equals ft. So r is x equals f over t. So 2 pi r is x values here. So it's 2 pi. Take the antiderivative from a to b. Okay. Take antiderivative, not actually 1, not actually y values, it's t values. T from a to b, and 2 pi r is x equals ft, so it's x values. 2 pi f over t, 2 pi x times the change of the curve. The change of the curve is dx over dt square plus dy over dt square, and then square and dt. This is the curve. We did the arc length. We have d. This is the arc length, and times dt is a small change of the arc length, and this is the surface area of the small one. And take the antiderivative from a to b. So that's how you have the formula. It's pretty straightforward formula. Okay, so let's look at examples. Find the area of the surface generated by revolving the curve about each given x-axis. Find the area of the surface generated by revolving the curve about each given given x-axis, either x or y, x-axis or y-axis. So first one, I give you x equals 2t, y equals 3t, and 0 less than equal to t less than equal to 3. So I'll give you 2 minutes. Try this one by yourself. Oh, I forgot to say what x-axis, right? So the first one, x-axis. Okay, so let's look at together. I want you to practice, then we can do it again. S equals 2 pi. T is from 0 to 3. Since this is x-axis, x-axis revolution, the curve about x-axis, so it's 2 pi yt. Okay, so it's 2 pi y, 3t times square root of dx of dt, so it's 2 square. dy of dt is 3, so it's 3 square dt. So its answer is 2 pi from 0 to 3. 4 plus 9 is square root of 13t dt. So then it's 2 pi, well, you multiply it out. 2 times 3, 6. 6 square root of 13 t square over 2. The antiderivative of t is t square over 2. Plug 0 and 3 into it, so you get 6 square root of 13 times 3 into here is 9 over 2. 0 into here is minus 0. So the final answer is 27 square root of 13 pi. Okay? Does it make sense, everyone? Okay. So next, I would like you to try, how about we revolve it with respect to y-axis? Okay, try this one. I'm going to call a student to tell me the answer. All right, so I'm going to call a student here, see if you can tell me the answer. Caleb, could you please tell me what you got?
I wasn't too sure about this, but if we were to integrate along the 0 and 3 the same way, I think it would just be 18 square root of 13 pi.
Very good. That's right. You got it right. Okay, so it's 2 pi times from 0 to 3 and 2t square root of dy dx over dt squared. So it's the same. The only change is you change the x and y. If this is a 3t, now this is a 2t, this is 2 pi x. So that's the only thing you need to change the formula. So it's going to be still square root of 13t dt. So you get the final answer is 2 pi is 4 pi square root of 13 from t squared over 2 from 0 to 3. You plug it in, you got 18 square root of 13 pi. Perfect. Okay. So is this one good, everyone, now? Okay. So next we can try a special one, see what we got. If your x equals 5 cosine theta, y equals 5 sine theta. Okay, we revolve it. So 0 less than equal to theta, less than equal to pi over 2. And then we revolve it with respect to y-axis. Like, have everyone try it? Okay, so now we got the area S. I would like to ask a student, tell me what you got. Do we have any volunteer? Okay, I'll ask a student here. Travis, could you please tell me what you got?
I didn't finish it all the way, but I got 2x equals 2 pi from 0 to pi over 2.
2 pi from, okay, 0 to pi over 2, very good.
And then it's 5 cosine theta. And then the square root of 25 sine squared theta plus 25 cosine squared theta.
Okay, is the derivative of this is sine square, derivative of this is cosine, and square is 25, that's for perfect. So what do you get next? So it's 22 pi from 0 to pi, 5 cosine theta. You got this is what? Sine theta square plus cosine theta square is 1. So it's 25 times 1 is square root of 25, which is 5. Make sense? Because this you can factor 25 out is sine theta square plus cosine theta square. You got this is 1. So 25 times 1 is just a 5. So now it's much simpler. Oh, pi over 2. It's much simpler now. So it's 2 pi times 5 is 25 times 25 derivative of cosine, sorry, antiderivative of cosine. Antiderivative of cosine is sine. Plug 0 and a pi over 2 into it. So I'm going to call a student here, see if you can help me finish this. Bella, could you please help me finish this?
I don't remember what
Sine pi over 2. Alright, so if I draw the picture like this, this is 0, this is pi over 2, this is pi, it's 3 pi over 2. I don't need that. So can you tell me what is the sine pi over 2 now? This is y equals sine x. Okay, so what you got? So plug in, so it's 2 times 25. Can you tell me what you got? 50 pi. Okay, plug pi over 2 into the 1. Plug 0 into here is what? What is sine 0? Bella, could you please press your button?
Yeah.
Okay, 0, very good. When you answer a question, I think you need to press the button, otherwise I can't hear it. Alright, so 50 pi times 1 to 0, so it's 50 pi. Okay, very good. Thank you very much. Alright, so we got the answer is 50 pi. When we look at the picture, it's actually really hard, really simple calculation. If you know this formula, it's 2 pi x dy of dx squared. Okay, so now my other question is, can you tell me what is the graph of this function? What is the graph for this parametric equation?
Is it just a horizontal line?
Horizontal line. You mean, oh wait, you mean this way? Can anyone tell me what is the graph of this parametric equation? Horizontal line doesn't work because horizontal line is x equals something, x equals 5. There is no y for x. If it's horizontal, for example, it's x equals 5. But where does I have y is changing? Because horizontal line, y never change. So you may have to think about that again. And anyone else? It's a circle, very good. It's 5 cosine theta is a circle. And the radius is 5. Now, actually, it's changing from 0 to pi over 2, so it's from here to here. You revolve this circle, just the 1/4 of the circle, revolve it with respect to y-axis. So you actually get to here, you get a half of a sphere. You get half of a sphere. Everyone knows that this circle is x squared. If you do that, it's x squared plus y squared equals 25. We did this one like for several times. Okay, x squared plus y squared 25. And now this is a half of a sphere. The area of the sphere formula, S is what? 4 pi r squared. So the whole sphere, if you do the whole sphere, is 4 pi r squared. And it's 4 pi times 5 squared, which is 100 pi. But now, since I just revolved this side, I only have a half sphere. So it's half of S equals 1/2 times 100 pi equals 50 pi. So you still get exactly the same answer as this one. Okay? This method compare with the rectangle. For example, you do x squared plus y squared equals 25. You do y equals square root of 25 minus x squared. Compare with this one, this is much simpler because you don't have to even do any substitution. If you do this in the previous work, and we use the rectangle one is 2 pi and RT times square root of 1 plus, I think it's y f prime of square, and then dt. It would be much, it might be more complicated because you probably have to do some substitution. But in this way, the parametric equation is much simpler if you do this. You see the integral here from here to here, there's nothing really difficult this way, right? It's all just the this is 5. That's just a very simple antiderivatives. All right. So this is why I introduced the parametric equation for that. And I'm going to write several things in case, since you didn't tell, since some students still have like not very familiar with that. Can anyone tell me what is the graph of this one? Ellipse, very good. Okay, so I'm going to write another one. I think it'd be fine, right? X squared. Okay. So can anyone tell me what is this one? A parabola. Very good. Okay. Alright. So like this kind of equation we did several times in the previous section. What you need to do, you just need to switch x over 5, you got a cosine. You only use the you use trigonometry identity. Cosine theta square plus sine theta square equals 1. That's what you need to use. So here x over 5, you just do x over 5 square plus y square over 3 square equals 1. This is the ellipse. This one you use secant theta square minus tan theta square equals 1. So secant theta square, this is x over 5 square plus, minus. You don't have to use the 5. You can change this into 3, that's fine too. So over y square over 3 square equals 1. Since the x over 5, this one gives you secant theta square. This one gives you minus tan theta square equals 1. So whenever I give you this formula, this equation, it should be like, right now you have to like think about, okay, you should be just use either one of this. Either sine theta cosine theta square plus sine theta equals 1, secant minus tangent equals 1, right? So 10 point, next one we're going to look at 10.4. Polar coordinates. And the polar graphs. We're going to look at that polar graphs again actually. This kind of graph, we're going to do a lot in the next section. So polar coordinates and the polar graphs. What is the polar coordinates? Polar coordinates in the x rectangle direction, in the rectangle plane, we have x and y values. Give you x value, give you y value. So polar coordinates, if you take trigonometry, you probably know this. It gives you a point, the point decided by the radian, okay? So which is r, and the angle theta. R is the length of OP. Give you OP and give you a direction theta, the angle theta. The P is determined. Okay, P is determined by this length and the angle. Well, in the rectangular system, P is determined by x value and y value. X value is this one, y value is the one. So it's determined by x and y. In the polar coordinates, the point is determined by the length of the radius. Okay, we call this radian. Okay, the radians, and then the angle of the theta. So R is the directed distance from O to P. So theta is directed angle. Okay, counterclockwise this way. From polar axis to segment OP. Okay? So now, if I shift a polar coordinates into, for example, this is the R, this is the theta, this is the P. If I shift this one into a rectangle coordinate system, so can anyone tell me how is it possible for me to find the X coordinates and the Y coordinates? I give you the hypotenuse. OP is actually like a right triangle here, right? You have X coordinates and Y coordinates. Can anyone tell me what do you think about the X coordinates? Give you R, give you theta. X equals R cosine theta, perfect. Y equals very good. Y equals R sine theta. Okay. So if you convert the polar coordinates into rectangular X coordinates, you get X, Y. Actually, this is X. I should convert this way. Convert X coordinates is R cosine theta and R sine theta. And this is the X value, this is the Y value. Okay. So this property gives us a theorem of coordinate conversion. Okay, so basically the polar coordinates, this is just a big theorem right now, right? So actually it's pretty simple, it's not big. And the coordinate conversion, conversion, the polar coordinates R and a theta of a point are related to the rectangle coordinates x, y of the points as follows. So basically, I just write that what we just discussed again. What we have is x equals r cosine theta, y equals r sine theta, and the second, tangent x, so tangent theta, you have the angle. Tangent theta, if you take the trigonometry, tan is opposite of opposite of adjacent, right? It's y over x. Y is opposite angle, x is adjacent angle, so opposite of adjacent. R is the hypotenuse, so y over x, and r squared equals x squared plus y squared. This is based on trigonometry. This is the Pythagorean theorem. A squared plus b squared equals c squared. R is hypotenuse. X squared is the adjacent. Y is the opposite side. So it's the Pythagorean theorem. This one, okay. This tan theta is opposite of adjacent. This is the trigonometry. So now we're going to do several examples. Find the corresponding rectangular coordinates of the points. Alright, so first one, 8 pi over 2. So I want to find the out of them. I'm going to write several. Okay, -2, 5 pi over 3, number 3. Okay, just these two first. I'll give you 1 minute to finish this one. H2, I'm going to call student to help me to tell me the result. Okay, so I think I'm going to ask the student tell me this one. What is your rectangle coordinate? Okay, so I'm going to call student here. Matthew, could you please tell me what you got?
Did we find r by plus we use like r squared equals x squared plus y squared into this one, so it would be 8 squared plus pi over 2 squared.
Oh, this is corresponding coordinates of the point. This is the polar coordinates. We're looking for x and y. We're using this formula. You see, this is r, this is a theta, this is the angle, this is the radius. So this is a theta. We just need to plug it into here. We'll find x and y. Find the rectangle coordinates. So basically, we do the conversion. So what is x? What is y? This is r and theta. Convert the polar coordinates into rectangle coordinates. So x is 8 times cosine power of 2. Y is 8 times sine power of 2. So 8 cosine power of 2, which is?
That would be 0.
This would be?
8.
8. Perfect. Thank you very much, Matthew. So when you do that, you can do that is 8 pi over 2. So this is 0. This is pi over 2, right? You do 8 pi over 2 at this angle, so it's 8 here. And at this point, you can tell that this x coordinate is 0, so it's 0, 8. Right? If you look at the picture, it's right. So the polar coordinate, the rectangle coordinates for this one is just a 0, 8. This is r theta, this is x and y. Okay. So next one, I'm going to call another student here. Jasper, could you please tell me what this is? Okay. What you got for perfect? Okay, so this is -1 square root of 3. Perfect, very good. So you go -2 5 power over 3. So -2 5 power over 3 actually is going to have to do 2 is right here to here. Okay, I will explain later in the future, next class probably, how do I draw the -2. Okay, you cannot draw -2 5 power of 3. You have to draw +2 but another angle. Okay, but you got the angle, you find the coordinates is -1 square root of 3. Okay, so next one, find the polar coordinates. Based on rectangle coordinates, based on x and y. Find r theta based on x and y, so backwards. So number 3, I give you the xy, which is 2 and 2. And I want you to find out what is r and theta. Okay. After you are done, I'm going to ask the student here. You have R, you have theta is based on this one here. Okay, R and theta. Now X and Y is given. I ask you to find R and theta. Okay, so I'm going to call a student here. So, Eric, could you please tell me what is R, what is theta? Is Eric here? Okay, your theta is right. Theta equals, because tangent theta equals y over x. Tangent theta equals 2 over 2 equals 1. So you got theta equals tangent inverse of 1. Well, tangent inverse of 1 is power 4. That's good. You got power 4 right. But r equals square root of x squared plus y squared. X squared is 4. Y squared is 4. So it's square root of 8, which is 2 square root of 2. 2 square root of 2. Thank you very much, Eric. Alright, so now we just finished today right here. We're going to continue next week. And since tomorrow we're going to look at your test exam 3 questions. I think some of you probably have questions about several questions for sure. And also we are looking at the bonus point. Since none of you have make it right, the bonus point. But it's a very interesting question. I would like to explain to you. Actually, I'm mentioning something about the bonus point, the bonus question in the class. If I explain to you tomorrow, you will think about, oh, I've already explained this before. Okay, so tomorrow we're going to do that.